All right, so tonight we're going to look at exponent rules. Instead of just jumping right into topics and questions, I figured I'd actually go over the exponent rules and explain to you what they are and how they came up, and then we'll go into the topics, because I think this is one of those concepts that if you understand the rules and how they work, the other stuff actually becomes really easy. So let's look at the first one. So we have the first rule is x to the a times x to the b equals x to the a plus b. So this is the rule where the bases are the same, you add their exponents. So if you think about it, if we do 2 to the third power, that is, and then we'll times it by 2 to the fourth power. So 2 to the third power is the same thing as saying 2 times 2 times 2, right? 2 to the fourth power is the same thing as saying 2 times 2 times 2 times 2. And if you think about that, that's literally the same thing as saying 2 to the 7th power, because I have 7 2's now. So that's kind of why that rule exists. So whenever you're multiplying things that are the same base, you just add their exponents. They have to be the same base, though. So for example, if I had 2 to the third times 3 to the second, I can't do anything with that. That's literally stays that as it is. So there's nothing I can do with that one. That would just be 2 to the third times 3 to the second, because the bases are different. Okay? All right, any question with that one? That one's pretty straightforward. All right, so the next rule, we have x to the a over x to the b. So in division, if multiplication is addition, division would be subtraction. Yes.
Problem above, 2 power of 3, and then on the other side, never mind.
Okay. So when you're doing division, we're doing subtraction. So if you think about it as we have 2 to the 5th over 2 to the 2nd, that's 2 times 2 times 2 times 2 times 2 over 2 times 2. When you're dividing, we can reduce things by canceling. So we can cancel out those 2's and those 2's. And at that point, I have 2 to the 3rd, which is 5 minus 2. Okay, so when we're looking at division, it goes back to subtraction. All right. The next couple rules looks at parentheses. So if I have x to the a raised to the b power, this is the one we're multiplying, and it's going to be a times b. So if we look at, we'll do 2 to the third to the second. So that would be 2 to the third times 2 to the third, which we already said when we were adding, that would be 2 to the 6th. So the quicker way to do it is just to look at that and multiply them. Okay. So anytime you have parentheses, you're multiplying their exponents. All right. The next one with parentheses is when we have multiple things inside the parenthesis. Just like when you have something out in front of a parenthesis, if you have an exponent outside the parenthesis, you distribute it to everything on the inside. So this would be x to the a and y to the a. You can combine rule 4 and rule 3. So if I had x to the m and y to the n raised to the a power, it's going to be x to the an and y to the an. You're going to multiply those exponents. So same concept, you distribute and you're going to multiply by the exponents that are inside. So if there's no exponents, it just ends up being there. But if you do have one, you distribute and multiply those exponents. Yeah. And the base is, this one, unlike the rest of them, the base doesn't matter because you are bringing it to everything inside of it, including if there's a number in front of it. All right, any questions with those rules? All right. So we're going to look at 2 more rules, but before that, I want to actually do a nice little, quick little review of what exponents means. So what's 3 to the 4th power?
Like not.
Yeah, an actual number. What's 3 to the 4th power? Yeah. It would have been easier if you did 3 times 3 is 9, and 3 times 3 is 9, and then 9 times 9, which is 81. And when you did it the way that everybody does it, they go 3 times 3 is 9, 9 times 3 is 27, and then they get stuck.
Yeah, that's the one. I'm like, wait, what number?
Yeah, it's like that's 27 times 3. Yeah, remember, you can split them up in any direction you want. So it's like, it's easier actually to do 3 times 3 is 9, 3 times 3 is 9, and then multiply those 2 together to get the 81. So that would be wrong, which is why we're going through this quickly. What's 3 to the 3rd power? That's 27. What's 3 to the 2nd power? 3 to the 1st power would be just 3, right? What's 3 to the 0 power? Wrong.
No, 1 over 3.
Nope,
No.
that's negative. This one is 1. All right, so this is why I like doing this little exercise. All right, because this is one of those rules that everybody looks at and goes, "It." When you were in high school, and you got taught this. Everybody gets taught this, and I guarantee at some point, the teacher might have shown you like this way, but a lot of teachers say the rule, just remember anything raised to the power of 0 is 1. They never actually explain why. So you memorize it, and since you don't actually understand why, you never remember it. You always think anything 0 is 0. Let's look at it. If I went from this way, so if I was going up, right?
Yeah.
So this way, it's times 3, right? That way is times 3. That way is times 3. That way would have to be times 3. If it was a 0, that rule wouldn't make sense. Right? What's 1 times 3? It's 3. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. The pattern has to hold true. The other direction is also true. If I go the other direction, I divide by 3. Right? So same thing's got to happen. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. So the pattern has to hold true. If it wasn't a 1, the pattern wouldn't hold true and you'd be broken here. Now, that pattern has to continue to be true as we keep going. So while we have, let me go over here, we'll write down this, the 5th rule before I go on to the 6th rule. The 5th rule is anything raised to the 0 power is always 1. Okay, so, and now we kind of understand the rationale behind that. But now, we'll look at the 6th rule, because if we continue this pattern, the next one down would be 3 to the negative 1, right? Because I'm going 4, 3, 2, 1, 0, negative 1. That'd be the next one. So let's look at my pattern stuff. So since I don't have it, I can't necessarily do my multiplication, but I can do by division. What's 1 divided by 3? 1/3. Okay, and now if you look at 1/3 times 3, it does give you 1. If I do 3 to the negative 2nd power, same process. Divide by 3, which is 1/9. Okay, we'll do one more and see if you can see a pattern to this.
Okay.
3 to the negative 3rd, I divide by 3 again, will be 1/27. Now, look at these 3 down here compared to these 3 off the 7. Those 3 right there. What do you notice? They're the same, But what? Right. They're the same, but it's underneath the 1. So 3 to the first power is 3. 3 to the negative first power is 1 over 3. 3 to the third power is 27. 3 to the negative third power is 1 over 27. So a negative exponent just reverses, changes its place.
Kind of like how we did.
So if I have a negative exponent, so x to the negative n power is 1 over x to the n power. And the opposite, that's also true. So if I had 1 over x to the negative n power, that is x to the n power. So the negative exponent switches its location in the fraction. So it either puts it down the bottom or moves it up top if it was down the bottom. Okay. And those rule 5 and 6 are because the pattern has to hold true for all numbers. So if you change the pattern, things get all messy. So, and mathematicians really are lazy people. We like rules to just make sense for anything. So we want to make a rule that always works. And this is why we have x equal to the 0 power equals 1. And the negative exponents become fractions instead of like negative numbers or something. All right, so those are my 6 rules. And they're so small, but if you actually see it on the screen later, you probably can read those all. But those are the 6 rules. All right, those make sense? Now, let's use them. All right. So the first couple topics are actually pretty simple. It's just giving you fractions. So actually, power, and they always give you 2 in this topic. Oh, actually, let me do this one. All right, so when you're looking at questions like this, they actually want an exact number. The reason they're doing this one is to have you understand what the parentheses actually mean in terms of the process. All right, so, and this first one, when you have the 2 outside, the exponent goes to everything on the inside, including the negative sign. And that's the piece that most people mess up. So it's times that, and it's times the 5. So what's negative squared? What's a negative times a negative? Positive. So my negative sign is gone. So now 3 to the second power is what? That's 9. 5 to the second power is 25. And that's my answer. Then I have the next one, and notice I don't have parentheses. So that squared is only on the 5. So my answer is going to be negative 3 over 25. All right, it's really making you think about where that negative sign is and what the negative sign means. Another one you'll see in this one is like this. Or like this. So now that the first one, the negative sign's on the outside, right? The first one. So that negative sign is just going to stay there. I'm not doing anything with it. And now this 4, this 3, I have to do it with both of them. So 4 to the third power is 64, and 5 to the third power is 125. Use a calculator for these. If you don't remember these in your head, use a calculator. If you can't, at some point before you leave, whatever calculator you're using, make sure you can actually do exponents on it. If you can't, I will show you how to do it, because I know some people, you try to use the one on their phone, and sometimes the exponents is not straightforward in how you're going to do it. So, but the thing I wouldn't suggest doing is try to type the entire thing into your calculator at once and try to get the answer. Because, yeah, you're going to use that little tilde key. Or not the tilde key, the, yeah, I can't think of the name of it off the caret key. So don't try to type the whole thing in at once, because sometimes on your calculators, it will do them incorrectly if you don't put parentheses in the right spot, and you're not going to know where you're messed up. So notice how I'm doing them individually.
Yeah, because parentheses, you need those to be able to separate things.
Yeah, and that's going to be a trouble on some people's calculators. So this one, I got to do the 3 to everything. What's negative to the third power? So what's 3 negatives give you? That would be a negative. So then 4 to the third power is 64, and 5 to the third power is 125. So actually, these two answers come out to be the exact same thing. That's fine. Just because it was to the third power and not to the second power. So this negative sign stays.
This is why people make mistakes.
Yes, this is exactly why people
You're
make
not
mistakes.
confident that you're doing it if you get the same.
Right. And they look different. And that's why, like, the number one mistake people make is here. Is with the sign inside with the exponent. And that's why if you notice, a lot of people say, oh, do -4 to the third power, which you could do. But notice I'm doing them as separate pieces, so this way you don't mess that up. Make a conscious effort to look at the negative sign as an actual piece that you're distributing to. And you're less likely to make those mistakes with the signs. All right, I think, let's make sure there's no other crazy ones. Yeah, that one's straightforward. I'll do that one real quick. All right, so the next topic that we're going to look at gives you something like this. It says b to the third times b squared. And then it gives the same thing, b to the third times b squared. But this one has a beta. So this one, it's a really stupid topic. It's literally making you understand the rule. So the first one, they're actually looking for 5 b's. And the second one, they're looking for you to put a 5 in the box. All right? It's a really stupid, easy topic. Amazingly, people get it wrong.
I aced it.
Awesome. But it's one of those times that some people like, because they're not understanding what they're asking for. I don't think it'll actually let you put an exponent in the first one, which helps. So just keep that in mind. So that's what I said. The beginning topics are pretty straightforward and pretty simple. So, all right. Next one, we have x to the second times x to the fifth. What's my answer? X to the what?
7.
Awesome. I'm glad you guys said 7 because it's wrong.
8.
The answer is 8. However, why would you have made that mistake? Because you've forgotten that one right there. Remember, if there's no exponent, it is not a 0, it is a 1. So I'm so glad you guys said 7 and not 8, so I can explain that. It's 8. So yeah. But it's fine. Those are the common mistakes people make. So if you said 8, I was going to say, wait, how did you get 8? And I was going to make sure you actually explain that part. So remember that if there's no exponent there, there's a 1. All right, a lot of people want to mentally put a 0 in there. If there's a 0, they have to put the 0 because that actually means the answer is 1, not x to the first power. So if there's 1 there, there's a 1 up on top of there. So just something to keep in mind. All right, let's do it like that. So we have 2x squared times -3x to the 5th. All right. So when you have a problem like this, and these are just going to get progressively more complicated with more letters and more numbers for all intents and purposes. This is the main group of topics actually that this Alex gives you. You want to look at them in pieces, all right? So the first thing we're going to want to do is we want to put things that are the same together. So I always look at my numbers first. So what's 2 times -3? -6. So do the numbers first. All right. And now let's do our letters. So now I have x's. So what's x squared times x to the 5th? When I'm multiplying exponents, I do what to the variable? Or I'm adding the, sorry, when I'm multiplying variables, I add the exponents. Said that backwards. So that's my answer. -6x to the 7th. Right? So just do it in pieces. Don't try to do it all at once. The 2 isn't attached to the x squared, but it's a separate piece. It's 2 times x squared. So I could easily rewrite this problem as 2 times -3 times x squared times x to the 5th, because there's really multiplication across the whole problem. So I can make multiplication any way I want. Let's actually do this one. So it's 2w to the 3rd, 8y, 3y to the 6th. W to the 4th. All right, so here's my problem. And it's written just like this. Okay. Remember, times is no different than parentheses. All right, so this is no real different than the last problem we just did it here. The only difference is there's more numbers and more letters. And that's why I said these problems just get more progressively complicated by adding more things to it. But I still can do this problem one piece at a time. So the first thing I'm going to deal with is my whole numbers. So 2 times 8 times 3. And remember, you can do these in any order you want. What's 2 times 3? 6. What's 6 times 8? Right. That's a lot easier than doing 16 times 3. Okay? So use it and move things around and make it simpler to do in your head, or just use a calculator. So I got 48. So I've now taken care of those 3 things. Now, let's look at our letters. Even though there's no multiplication sign between the y to the 6th and the w to the 4, there are times. So it's no different than the y to the 3rd or the w to the 3rd and the y. We're just multiplying. So let's look at my letters first. You typically want to do them alphabetically. It does not actually matter, though. Alex will accept it any direction we want. The proper way to write it is alphabetical. So w to the 3rd and w to the 4th gives me what? W to the 7th. So we've now dealt with the 2 w's. And now let's deal with the y's. So I have y to the, did you say 6 or 7? Okay. Y to the 7. Don't forget that one right there. Okay. Simple enough. This is why she said you're just going to blow through these topics.
Why is all the topics the same thing?
No, but if this came that easy to me.
They get progressively more complicated, but it's not much different. So, all right, so let's add in, now they're going to add in parentheses with exponents outside. So this one's going to be v to the what? Right. We just multiply it 3 times 5. It's just using the rule we did. If I had 6x to this, actually, let's not do 7. I'll be nice. We'll do 6x squared. So actually, I'll show you. So you can, and I'm going to actually try something real quick in Alex. I want to make sure you can actually do this. Because I'm almost sure you can, but I want to make sure. Oh, nope, it actually does want you to evaluate, but it won't mark you wrong. But so they'll give you numbers, that ones that you actually can do out, which is kind of nice. So we have an exponent outside. We distribute to both of them. A lot of people forget to do it to the number. Don't forget to do it to the number. What's 6 squared? 36. And then we have x squared. I tried to put in 6 squared. It told me to evaluate the number. That's what I was trying to figure out if it'll let you do it. So 36x squared. So now if we do 3x squared y to the 4th. If you want, you can just distribute and actually just put 3 to the 4th there. Then we got to multiply, so x to the 8th and y to the 4th. So you can just do that as one step and then just make sure you do your number. So this was going to be 81. So you can do the distributing of the exponent first and then just do the numbers afterwards. That's fine.
81x to the 8th.
Yeah. Yeah. All right, so yeah, actually we're right over here. So this one's, so people can see it and not get confused later on. So get 81x to the 8th and y to the 4th. Again, same thing we're just doing, we're just distributing. Notice, all these goes back to those 6 rules that we did at the beginning. It's just adding more stuff in. And to be fair, I've already gone through 10 topics. All right, so let's actually do that one next. So let's go another more complicated step. Let's put these together. So we have 2x to the 3rd, y to the 2nd, to the 3rd times 3x y to the 4th, z to the 3rd to the 2nd power. Notice, nothing more, just more letters, just more numbers. All right, it's nothing crazy. What do you think we should do first? Let's get rid of my parentheses by distributing. So we're going to take the 3 and we're going to multiply it by everything over here. So 2 to the 3rd power. Then I have x to the 9th power and y to the 6th power. Distribute. Forgot that one automatically does my arrows for me. So I got 3 to the 2nd power, x to the 2nd, y to the 8th, and z to the 6th. So normally, my first step when I'm doing the exponents and numbers, I won't typically multiply them together, especially when we start looking at division, because I want to see if I can do anything with them first. Because sometimes you can simplify things down, or just like dealing with it as a variable. I won't typically do that step until the very end, where I'm actually going to finally take care of those numbers and stuff like that. Here, there isn't anything else I can do with them, so I'm kind of at the end. So that's 8, and that's 9. So I have 72 is my number. And now let's go through my letters. I have x. X is to the what? Right, because I'm 9 and 2. Y is to the 14, 6 and 8. And then I only have 1 z, so I just put that one there. Okay, that's my answer. All right, what's the only thing I haven't done yet? What's the only, well, the only thing I haven't actually put on the board yet, except for that first one there. I haven't done anything with fractions. That's next. But think about fractions, they're division. So we're going to use the division rules. Okay, so let's look at it. So we've got 45, x to the third, y to the second, over 9, x to the fourth, and y. All right, so here's, yes, there's some easier questions than this one, but I've already gone over the rules. So here's how I would typically do these problems. I always do my multiplication first. So if there's anything on the top and the bottom, I will do those things first. And then the next step is I look up and down. All right, so in this case, I have 45 divided by 9 is what? Is 5. Now, when I have fractions, we're doing what to the exponents? Subtracting. So what's, and you always take top minus bottom. So it's 3 minus 4. -1. What's 2 minus 1? 1. Remember, don't forget that's a 1. Okay. If you don't, if it's something that's going to mess you up, put the ones. Right? When you're missing an exponent, put a 1. So this way you have that visual reminder that it's there. All right, so I've got 5x to the -1y. I cannot leave it like this. So your very last step is to deal with any negative exponents or 0 exponents. So that x to the -1 is going to go where? It's got to go down the bottom.
Yeah.
Any negative exponents, just switch location. If it was on the bottom, it goes to the top. If it's on the top, it goes to the bottom. And that's my final answer. Let's do... All right. Ooh, I didn't want to erase my whole line. Not what I wanted to. Yes, totally made it up off the top of my head. Do you like it? Oh, you don't? Oh, darn. Sorry. We're going to do it anyway. Not what I wanted to do. I know, that's on purpose. All right. I honestly can't make a more complicated problem. All right, and Alex can't make a more complicated problem. It's like, yeah, they might be able to add a few more letters, but in essence, this is encompassing every possible step that I could have. Okay, so here's my steps for solving these type of problems. The first step, remove parentheses. Okay, so step 1, get rid of my parentheses. So in this case, I'm going to distribute. So I have 3 squared, x to the 4th, y squared. 5 to the 3rd, x to the 3rd, z to the 9th. Over 5x squared, y, 3 to the third, and z to the 12th. So notice, I did one thing. Okay? I just got rid of all my parentheses. All right? Don't try to do a million things for this problem at once. Okay? Because when you try to do too much, that's where you're going to make those little mistakes. Okay? Second step. Multiply left to right. So I'm literally going to look at the top and multiply across, and then the bottom multiply across. So I have 3 squared, 5 to the third, x to the 7th, y squared, z to the 9th. Bottom, 3 to the third, 5, x squared, y, z to the 12th. So if you notice when I'm doing these, every step makes the problem smaller. So the first one, I got rid of my parentheses. The second one, I was putting letters together. So I only have one x on the, I only have one x, one y, and one z on the top, one x, one y, and z on the bottom. And I have one of each number. So basically, depending on how complicated, make it, how many things, every step compresses it down. After the second step, I should only have one of each thing on the top and one of each thing on the bottom. Okay? After the next step, I should have one of each thing. Because the next step I'm looking, I'm going up and down. So step 3 is divide up and down. So I'm going to have 3 to the negative first power, because 2 minus 3, right? I have 5 to the second power, because that's 3 minus 1. And notice everything's lined up. Because when I wrote them in numerical and alphabetical order. So everything is kind of lined up right above each other. Then I have x to the 5th, y, and z to the negative 3rd. Sure, that's fine. Absolutely. See, problem getting smaller. Now I only have one of everything. And we're only one step to go. The last thing I'm going to deal with is remove any negative exponents. And zeros. So that 3, so at this point I put my fraction, the 3 is going to go down the bottom. 5 squared is 25. X stays up top, y stays up top, and z goes down the bottom. And that's my answer. So remember how we were solving equations and I said 5 steps, you can solve any type of problem you want? Same concept here. I could fill the back wall with a problem like this. You could do it in 4 steps. There you go. Yeah, you have the whole problem. You're welcome. Huh? What?
I think you had to like.
The only thing I haven't added in is addition and subtraction. But we're not doing those today. We're not doing those today. Actually, that's it. I've done 16 topics today.
Oh, wow. Okay.
All the division ones, like there's like 6 topics with division. They're all easier than this. Actually, I don't even think there's a topic that's actually as hard as this one on the thing. They're all easier than this. So, but every one of them can be done with these 4 steps. It's just sometimes you might not have to do all the steps. Or you want, not going to have as many numbers or as many letters. So, huh?
Does it just shut off after 2 hours or?
Well, if we do it online, I don't think I put an exam timer on the last one.
No, I was just curious about our.
My pre-calc class, I've got it set for 3 hours. I haven't decided if I'm doing this one in class or online yet, though. So.
I was just curious.
But if I'm going to do one on the tests, I'm not going to do one as complicated as this.
Right. Thank you.
Because in all honesty, my goal is, again, to get you to make sure you understand the rules and stuff like that. So I don't need to give you one as complicated as this to do the rules. Like, I can give you simpler ones that can make sure that you understand the rules just as easy as I can do this one that you can make a million little mistakes in. The reason I wanted to show you this one was the same thing I did with the massive problem. It's like, no matter how complicated the problem is, it's easy to break it down. So don't get freaked out, walk through your steps and you'll be fine. So yeah, the only thing I haven't added in is the addition and subtraction, which we will do on Thursday. And even that's not too bad. So, because the rules are going to stay the same. The only difference is you're not going to be able to put things together as easily because you can't go things across addition and subtraction. So only if they're exactly the same you can. I'm trying to see what's the most complicated one that they gave you. Let's see. This is just two's problems. Oh, this one has 3, a number and 2 letters. Yeah. The only other thing that I actually didn't do one like it was like this. So if you have a variable and an exponent outside, I didn't do it, but it should be pretty obvious. You just distribute it to everything. It's just like the one with the negative sign in the beginning of the problem I did. So it's 3 to the 3rd, v to the 6th, and 4 to the 3rd. So 27 v to the 6th over 64. So just remember to distribute whatever's outside to everything on the inside, including the number, which is what a lot of people forget. Just like the other one, forgetting the signs. Once you see letters, you forget about the numbers. You're like, oh, it's attached there. No, everything. So that's it. That was 1/3 of the topics. And it's actually probably more than that because I think some of the topics actually repeat from some of the other sections. So I don't think it's actually that many topics. But that was 16 of the topics. So would you like me to go over anything else or you wish to be done?
You've got a handle on this and still don't. There were 2 things in our last test that I was like, why? I don't know why I just cannot remember.
Oh, I can go
how
over
we're
those.
doing it.
All right, let me stop this.